What? I'm presenting. Whoops. You didn't want to do that to me, I don't think.
No, I did not. I'm not sure exactly why I did that. I think just keep it. Just keep it. In a second. Just go to sleep.
Oh, is that the problem? Oh, thank you. Are we ready to go?
Yes, we're ready to go.
Okay, thank you all for being here after lunch. Welcome to BloomCon 2017. Actually, I want to thank Phil Polstra and all the students who have done the work for the conference. Really appreciate them doing that. This feels a little bit redundant because I see a lot of students and ex-students. Of course, I'm worried about the current students, and they're just here to butter me up or something. But the former students are here. I think it is very, very flattering. So I am John. A few of you who don't know me, I am John Riley. I'm a faculty member in the Department of Mathematical and Digital Sciences at Bloomsburg University. That's a new name change for some of you who have been out a few years, which lets us be called the mad scientist. Which we have happily adopted. That seems to fit us pretty well, quite frankly. A number of the speakers have talked about their background. My problem is my background in this field is, well, I'm a PhD mathematician from 1980, so that doesn't feel like the appropriate qualification to say. I have taken some of the courses that practitioners take, like NCASE courses and stuff like that. I think my most advanced course is I took the volatility course about 2 years ago now. And I am here, one of the 4 faculty members who teaches in this program. So thank you for being here. Oh yeah, the one thing I forgot to. Any questions? Those of you who have me and know I like questions. Questions are good. Okay. I was doing this sort of background. I teach file systems here quite a lot, and particularly the NTFS file system in our file systems course. And I was trying to build some more stuff for that, and mucking around, and I was starting to muck around and find out things, and so I ran into some problems. I want to talk about sparse files, what they are. And turns out, Dave Penny earlier referenced the FSUtil tool. It's really cool. If you like playing with files and file systems and doing a little bit less standard stuff, shall we say, you can use FSUtil, and I'd like to talk a little bit about that and then talking about NTFS sparse files, and with particular attention to file sizes, which got me on this road. I saw something and couldn't find any documentation for it. And I finally found one document. It was this old paper thing that I had printed off 10 years ago. It was the only thing which had the actual thing. Documentation. The standard Bible for file systems, Brian Carrier's file systems book, does not have this. So I had to kind of go in there and figure out what's going on. So let's start with talking about sparse files. And my mother taught me lots of little poems, and one of my favorites was "Yesterday upon the stair, there was a man who wasn't there. He wasn't there again today. Gee, I wish he'd go away." And so talking about sparse files is a little bit like that. It's there but not there. And so she taught me this poem many years ago. And so because I'm a scholar, I can't just say this is a little poem my mother taught me. I have to know whether she had a source. And indeed, there is a source for it. But it comes out from by this guy who wrote a little something about. And it turns out it's about 100 years old, which kind of shows you when about my mother was learning this stuff. So when we talk about sparse files, we're really talking about these things which are there but not there. And so a couple of ways of looking at it. It's a file which is large. Think 100 kilobytes at minimum, which is mostly empty. And of course, that doesn't make sense. And so when I say empty, I mean full of null bytes. So you can think about a sparse file as having maybe a block of 100 kilobytes of nothing but zeros. So that's one way of looking at it. Or I say file width, and I'm using the air quotes infamously. And so you can think of it that way. It's not empty, but it's got lots and lots of storage, which is full of null bytes. That's another way of looking at it. And we're not going to, this feels a little bit like compression, but it isn't, okay? Let me be real clear about that. It's not really compression. So think of it as an uncompressed file, which is larger than its allocated space, which kind of doesn't make sense. You know, how can something be, you know, that's like, yeah, you know, like saying, you know, this room is bigger than the Superdome. Doesn't make sense, right? It's a kind of conundrum you get into when you start worrying about sparse files. And so if you start getting a little bit more technical, it's sparse files with sectors of null bytes which are not allocated. So they're, you know, in some sense the sectors are, or clusters are there, or blocks are there. And it turns out that there are file systems like NTFS which make that possible. And then, of course, even if the file system knows, I like what Dave said again, it's always good to have be able to piggyback off a speaker. Dave said, you know, the file system is an independent entity from the operating system, the way I tend to look at things. Different operating systems can use different file systems and vice versa. So it's a little bit of a mix and match there. So, you know, those have to be provided for in the design of the file system, which is sort of the stuff I get interested in, and then also be taken advantage of by the operating system. And so what happens typically is if the sectors aren't, the null bytes aren't actually out there on the disk, where are they? And the answer is, oh, the operating system just spews them forth when they're needed. It's kind of a weird way of thinking about it. And so it turns out in the Windows world, the NTFS file system does allow for sparse files. The FAT file systems do not. And you know, this is a very tentative. My first reading on Linux is that Linux, the ext family, does support sparse files. I haven't done any research on that, so it's a very, very tentative yes. So these things are out there and hanging around and having fun. So there's, you know, why would somebody want to implement this stuff? Because it's obviously more work to be done in the file system design. It's more work to be done when the operating system is written. So first of all, you save space. You know, you don't have to throw out 100 kilobytes or 100 megabytes of null bytes. You've saved disk space. So that makes sense. The other thing is, if you think about, instead of reading 100 bytes off disk, 100 megabytes off disk, just let the operating system just spit out null bytes. So you get a speed up in time. And, you know, because you're not wasting space, may help with file fragmentation. So that's the advantages. There are some disadvantages because you have to track, the operating system has to track disk usage space. So, you know, if I have a whole bunch of these sparse files and they're not really taking up space, and all of a sudden I need space, it's not, is it really there or not there? So there is a disadvantage to using it. So complex tracking disk space can be more complex. Tracking user quotas can be more complex. You actually have a system with more than one user on it. They start using sparse files, then it gets problematic. And then you have this problem. Anytime you use a sparse file, does it blow up on you, and all of a sudden you've got things going on that you didn't expect. So these are obviously not forensics concerns, but they're out there and give you a little bit of sense of why they're in the background. So that's the sort of the 2-minute introduction to sparse files at the very high level. And I needed to, in doing this work, I was trying to figure out what the heck was going on with these sparse. So I needed some way of working with them, and they're not quite automatic. So I needed a tool, an FSUtil. If you haven't ever played with FSUtil and like playing around with file systems and doing sort of interesting things, FSUtil is a lot of fun. You can do stuff with it that I just don't know any other way of doing things. And you'll see an example of that. And it's particularly good with NTFS, which, you know, if you know anything about NTFS, it's a large, complicated operating system, and being able to do stuff with it sort of at the command line is very nice. It has to be, the one little caveat, has to be run with administrative privileges. But I was lunching with Bill Barnes, one of our computer people. Oh, yeah, we always give the forensics people computer administrative privileges, and we pay for it later on. So with that in mind, here's the sort of thing. Oh, yeah, here's the warning. Here's the official Microsoft warning about FSUtil. You must be logged in as an administrator to a member of the administrators group to use FSUtil. The FSUtil command is quite powerful and should be used only by advanced users who have thorough knowledge of Windows operating systems. Well, I probably don't fit into that because I'm not sure my knowledge of Windows operating system is all that advanced, but I went ahead and used it anyway. So, the burden was on me if I messed up. So far, I haven't caused major havoc, at least not to my knowledge. Sooner or later, I may find out I've done something I regret. So that's it. So here's the one little weirdness goes on with FSUtil because it is a fairly low level. So one of the things you can do with FSUtil is just create new files which are big of a specific size. So the way the FSUtil uses it, you write FSUtil, a command, and then some parameters. So the first line up there says create a new file named t.2 with 4K bytes. So it says, oh yeah, I'll create it for you. And there it is. And then what am I able to do? Set 0 data, which is actually, somebody was talking about delete this during the day. This is another way of zeroing data. But notice what I did. I started at offset 0 at the very beginning. I went for twice the length of the file. Does FSUtil complain? Nah, just did it. I'm not even sure what it did beyond that first 4K. I'm just hoping it was unallocated. So so there's the FSUtil kind of runs as it was, and it didn't actually even increase the size of the file. See, this is the only thing I shortened up the path names so these things didn't go off the screen. You see the actual size of the file didn't change as a result, which is kind of weird when you think about it. I threw in 8K bytes into a 4K file and stayed at 4K. And it didn't do sparse stuff at all. So this FSUtil is a little bit of like driving without your seatbelt on it, so you are warned. And that illustrates the general format of FSUtil. You write the word FSUtil, a space, a command, a subcommand, a sub-subcommand, etc., and then a couple of parameters. The parameters are not uniformly done. Some of them, for example, offset is just a number. Sometimes it's offset equals. So there are actually two different ways of seeing these parameters specifications come up when you use FSUtil. So when I'm doing this, I'm constantly doing FSUtil and just typing command because that shows me what's going on. So if you just want to find out the format, you just type FSUtil. And basically, you just go out as far as you know. So, if I want to know what options are for file, I stop here. If I want to know how to work with create new, I stop here. And then I get some little information about how to do it. And so this is an example of FSUtil create new and how it works and what you see going on. So here's one of the things you do. You just grab some disk space. What the heck? Go out, grab some disk space. Well, what's out there on disk? Almost anything. Okay? Now, there's this little bit of weirdness in doing that. That's not really what's there. I mean, we're in this really strange realm where things are there or not there. So although there's actually space allocated at this point. If you go in and check the NTFS MFT entries, it's allocated space. Okay? But it's not valid. So there's a second step to be done to validate it. And so there's this next parameter called set valid data. So I continue on the same, but so let's make all that valid. So whatever I grabbed is now mine. Think about that. Whatever I grabbed of some hunk of disk space is now mine.
But is it also possession of whatever is allocated in the first place?
Yeah, well, no, in the first place, here's where the details get messy, and this is sort of going to be where this whole talk goes, is there really isn't just one file size in this situation. And there aren't two. There are at least 3 and maybe 4 file sizes hanging around. And so the first command says, allocate some space, grab some disk space. The second command says, consider it initialized. Notice how I phrase it, consider it initialized. It's valid. Notice what I didn't say. I didn't say initialized, did I? And so this literally will grab disk space, and if there's stuff in that disk, from leftover, whatever, it's yours for the picking. Now, I told you earlier that my origins are of mathematics, and then I drifted into forensics late in my career. And then my cybersecurity isn't like many of yours, but that feels vaguely unsafe, right? You go out, grab, because what could be in there? Whatever's hanging around in an unallocated space. I actually was able to did this once and carved. There was a little bit of a GIF image, it's very small. And I was actually able to carve out a GIF image. I was lucky. I stumbled on. There was a GIF header, so and then I saw where it ended. It was very, very small, and I was able to carve out a GIF image just by grabbing. I have just stuff that was left over. So this FSUtil program has this really, really lots and lots of capabilities. And so if you ever want to play fun and games, and Dave earlier mentioned about testing, and our other speaker mentioned testing. If you want to test out things with files and file systems, FSUtil is a wonderful tool to play with. And many, many, many options you can play with and have fun with it. So this is what this is the start of that grab 4K data. And it's pretty obviously uninitialized. Now it's not it's not random. I mean, this doesn't look random because some things in there. So I don't know what it is, and it's obviously we're taking our chance. Go ahead, Dave. Wiped out with anything. When I say uninitial, I really should say uninitialized. It's whatever was there, you got it. So when I issued that create new, it went out, found some unallocated space, meaning disk space not assigned to a file, said, "Hey, it's yours." And then there's nothing. There was nothing I did. Has the data been written here? Yes. Now, it's what was ever left over. And this is a little bit about the man who wasn't there. It's there, but so there is this sort of weirdness going on in talking about this. But if you open, it could. I could get unlucky and just grab 4K of null bytes from someplace. But I will tell you, I've been doing this a bit recently, and most of the time I come up with stuff of one sort or another, which worries me a little bit from when I try to think like a security person, just being able, because what could you find out there? Just think about an attacker who's kind of gotten a little bit of elevated privileges, grabbing whatever he could find or she could find, and or just grabbing space and kind of not preventing it from being erased. That's what this does, because now the blocks that contain this stuff, and I hesitate to even call it initialized data because it's just stuff that was there, but the stuff that was hanging around is now kind of off limits for you start running a wiping program, it's not going to hit it. So it's a very interesting kind of scenario of what you could do with just those two little tools from FSUtil. So I think there are even this little combination of stuff under the file category, create new plus set valid data, I don't know, you guys can answer that better than me, must have security implications down the road. Some of you can write, if you get later on, you can write back and say, I found, now I've got another thing keeping me awake at night. And that's sort of a little bit of a side because that's not where so here are the two first level commands I was using a lot in preparing or doing the research for this. And one of the first commands you can use is FSUtil for files, and you can see this is the list of from a Windows 10 machine. It's not quite the list you would find on a Windows 8. This set EOF is new. That's brand new to Windows 10. It's not there in Windows 8. And you kind of think about what does it mean to set the end of file, 100 megabytes out there. I have to play around with that more and find out, but you can literally say, this is different from set valid data. It says, where's the end of the file? Oh, it's 100. Good, good.
It let you cross over a file that already exists, or will it stop you?
I don't know. I mean, this has become a little bit of a research in progress talk. In fact, I was finding out things yesterday afternoon to add to the talk. I mean, these commands are very interesting, shall we say. And I don't know. My guess is it obeys. My guess, it obeys. It will fragment if need be. But that's a guess. I have more research to be done. Go ahead. I use it a lot for producing files with interesting characteristics. Those of you who have to test what happens if, and where I'm headed, where I want to actually, and that's actually good because my problem was this: I was developing some course material for our file systems course about sparse files, and I wanted to be able to manufacture sparse files, and it's not quite trivial. They're not quite for free, as we'll see. In fact, I don't know. There's only one way I know of working with sparse files easily, and that's using fsutil with a sparse subcommand. So I wanted to do this because I saw something which didn't, and I was trying to get these guys built, and I couldn't find any other way. So if you want to just do things. If you want to just, I'm only illustrating two of these subcommands, file and fsutil, file and sparse. There are about 10 more. And you can, you can do, and this sort of answers, how I could answer Ben's question, query allocated ranges, or query extents, file IDs. So you can actually start doing queries using this right at the command line very, very quickly. So that's, if you're from a utilitarian point of view, you can use it that way. There's another command called, I'm trying to remember. There's a file system information. For example, if you want to know how big the cluster size is, you can pull that off. This tool has a lot of functionality at the file system level. If you don't care about file systems, you probably don't care about this tool. For whatever reason, I like file systems and looking at them and finding out about them. So there is this, there are lots of capabilities built in the FSU2. Just, if you want to see the top level commands, just type in, you go to command prompt with admin probably, type in FSU2, you'll see the first level, and you'll see file, and then sparse, and a whole bunch of others. And they all have various uses. So the two that I was using to kind of investigate the stuff I was interested in are fsutil and fsutil sparse. So one of the things that you see here is that fsutil enables you to allow, and I'm going to phrase it that way, a file to have sparseness. It's not quite for free. Windows supports it, but you actually have to tell the system that you want your file to be sparse. And my first sense of how applications tend not to use this, which maybe it's just because the applications I use don't naturally lend themselves to sparse files. And we'll see some other consequences of that. I have only been able to create sparse files using these commands. There may be other ways. The frequently mentioned use of sparse files. Suppose you have a big database with lots of empty space and don't want to waste disk. Sparse files could be very useful there. Now, I mean, big, we're talking, megabytes, gigabytes, whatever. And so these are there. And the other thing I mentioned about the applications, I double checked. I went to, are there APIs for these kinds of things? And the answer is yes. So if inside a program, it is possible to set a file to be sparse, equivalent to this set sparse, or set flag to set it to be sparse. And so you can actually do this in an application. So it is something that, in theory could happen. I haven't actually seen it in the wild yet, but I just a little aside. I think I'm the only person at the conference who's not actually a student or a practitioner. I am a pure academician. All my colleagues, Dr. Rich, Dr. Polster, they actually do stuff. I just sit in my office and play these kinds of games. And so, I'm kind of with that caveat, so I play around, find out this stuff, and see what happens. So anyway, that's those are the two big tools I was using for creating and playing around with sparse files and seeing what happens. My main tool for looking at things was active disk editor because it's my favorite price. Students, what's my favorite price? Free, right? So if you like playing around with a cheap editor tool, and it's better than playing with X-Ways because every time you do something with X, you have to reload the volume, do new volume snapshot. It takes 5 minutes, and an active disk editor you can kind of get in and out of that in about 2. So it saved me some time as well. So here's the comment I made earlier that it is possible to write programs which will create sparse files. And now I have to start talking about really what's happening underneath. And some of your questions actually are appropriate to this. So I'm going to use the word allocated storage to mean disk space, sectors or clusters, however you want to think of, blocks, actually assigned to a file. So that there's something in the file system structure which points to those sectors or clusters or whatever. So, and probably in whatever tracks cluster use, $bitmap inside NTFS is actually saying that cluster's now in use. As versus unallocated storage, just space which can be grabbed. Yeah, and this is the caveat. What's there? We don't know. Windows might fake it, incidentally. The interesting thing is, if you do that create new, Windows will dump out 4K of null bytes until you actually set the valid data. You can grab the space, but Windows says, well, you haven't really done anything with this. I'm going to just return zeros. And you've kind of taken this block off. You look at, and I did this obviously. And what happened after you create new? It looks like it's null bytes. But then if you go down another level, you find out there's actually stuff still in the clusters that are underneath that file. And then when you say set valid data, oh yeah, that stuff is okay. You can use it now, and start shipping it out. And that's what happened. It's a very strange kind of. Yeah, if you go down to the active disk, active disk editor or WinHex or something like that, then you start seeing what's down there at the very low level. And the other thing we will see is why, and how it keeps track of those things. Those are the file sizes that I was talking about earlier. What? Well, no. Let me phrase it this way. Can you execute null bytes? No. But could a executable have null bytes in it? Yes. Yeah. So I would think, if you had an executable, you could do it, providing whatever program you use to create the executable allowed for that. Yeah. If you, which might be an interesting thing, because then you can push around scripts which when you pushed around blew up on you. There's the blow up thing. I saw a hand to go up. I love questions. Well, no, it's allocated, so go ahead. No, it doesn't. That's the point. When I do this sequence of operations, create new and set valid data, doesn't do any initialization. It leaves you what was there. No, that's the one thing you can't do. That, to the best of my knowledge, you can't choose what you grab. It goes out and grabs because it won't grab space which is already assigned to a file. It will grab space which is unassigned, but there's, we all know there's lots of stuff out there that's unassigned but got data in it. I don't know. I don't know. It's one of those. If you ask Microsoft, they don't know either. My guess. I mean, it has to go in and look at the file system and see where is unallocated space. And it's like creating any new file. Where is the unallocated space? Except it doesn't do anything to that stuff that's allocated. Go ahead. Oh, you can afterwards. I mean, it's very, that's, in fact, in the FS util, you can do it fairly directly. Back up a few slides. These query things, this query extents, that will show you what's being used. That the extents is another name for data runs in this terminology, so it actually will show you the data runs. Go ahead. What? I don't know. I think I think what it does is uses whatever algorithm the operating system uses to allocate space, it uses that. And again, it probably depends on what versions of Windows you're using. This FS util has been around a long time. My oldest machine at the moment is Vista, and there's FS util on Vista. So it's not quite as much functionality, but it's all there. So you can actually find out by looking here. But what create new won't let you do is choose where you create it. It will just give you space someplace. Okay? So we have to worry about that. And here's the other thing we've been kind of circling around a couple of times. Initialized as versus uninitialized data. And I have to put, it's initialized if the data comes from some known source. Well, the known source might be whatever happened to be out there. And when we do set valid data, basically we're saying we're going to consider this stuff as okay. And so that's now considered initialized. So when I say data in a file which has values from some known source, that's pretty vague, and it has to be. As versus uninitialized content, basically, and this is some stuff we were looking at, data which sources unknown. And here's what Windows tends to do in this situation. It says, well, if it's not initialized, I'm going to tell you zeros. Which is a little bit, which was kind of weird, because, what I did at one point, I was playing with these things, so I opened this file, I looked at it in a disk editor. There was non-zero bytes there. I opened it up in HXD, my favorite hex editor, and it was all no bytes. Somebody was lying, and so here, as soon as you start letting Windows access things, it starts telling you no bytes if it's not initialized. So it always makes me a little nervous. And so here's a sparse file, kind of, and I'm going to say this is in the context of the Windows or maybe even NTFS. So it's unallocated storage, which has been initialized. So the file is this big, and we don't have any actual disk space for it. And when you ask for some 100 megabytes of data, we're going to give you no bytes. So, and which actually, this almost sounds nonsensical. It's unallocated and initialized. Think about that. That really doesn't make sense to say it's unallocated and initialized. But that's really the only way I can tell you what a sparse file does. There's stuff, it doesn't have space, but it will give you no bytes. So here's the creation process. So I created a 60K file. And this sparseness doesn't work too well unless the file is reasonably big. And I set the sparse flag, say, okay, this is a sparse flag. This is okay. If there's no bytes, you can make them sparse and not allocate space. And then there's a third part of what I found I needed to do, and that is set the range of where the sparse stuff is to whatever. And I just said the whole thing from offset 0 to the end of the file, all 65,536 bytes. And this is where I got surprised. Because in a normal non-resident file, I'm used to seeing 3 sizes. And these are the ones, because I have these battered copies of Brian Carrier's book, and he said there are 3 file sizes. Space on disk, allocated space. I've got to be very careful here. Allocated space is the first file size. Actual size is the second size, and initialized is the third. So after this, but then I also know that this 48 says The actual data for this, the data runs, I should say, start at offset 48. Well, here's the file size, dump, actual size dump, uninitialized, okay. And I see what many of you have had file systems too, so you know that the 0 in the first byte says it's a sparse file. Because I told you so, you remember it. Say yes, make me happy. Yeah, you'll remember that from file system too. So that this 0, 1 says there are, it's a sparse file, and then there are this many clusters of null bytes. So, oh yeah, that's stuff I've known for, 10 years. But what I didn't know is, wait a minute. 8 bytes for one file size, the allocated size, 8 bytes for the actual size, 8 byte for the initialized size. What the heck is this next 8 bytes? And Kyra's book doesn't have it. And I looked at my next reference, and I found one reference which told me what it is. That's actually, gotta make sure, that's the real size on disk. There's no space on disk for this file because it's all sparse. And so this is sort of the whole takeaway of the talk. That there's actually, when you do this kind of stuff, you actually get another file size which you normally don't see when you look at NTFS MFT records. And it does tell you something. It tells you how much space is actually used on the disk. And it turns out no space on the disk. Go figure. And the only reference I found is, as I said earlier, this old battered NTFS. Believe it or not, it's a visual. Let's see, what I'm trying to do. Visual Basic Programmer Guide to NTFS. And from a company called Relsoft that I double-checked last night. I can't find it on the web anymore. So I'm not. I haven't seen it. It's the only place where I saw this piece actually document this file size document. And then I started checking it out to make sure that it was okay. And I've got to keep a loop. So let me tell you a little bit about how this goes. There's, and you got a sense already from, the set flag and then the set ranges kind of stuff, what has to go on to have a sparse file. And it turns out that in the common header of an NTFS attribute, there's some flags at offset C, and if it's sparse, you actually get the 80 value in there, and of course it's only for non-resident data. And you actually will see this in there. In fact, back up to my example. This 80, there's a flag. That's the flag right there that says this is going to. And when I say sparse, I mean meaning it can have sparse. It could actually have some non-sparse stuff as well. That's actually possible mixed in. So that's the first thing. It turns out, if you look at the permissions flags in the standard info or the file name attributes, there are actually some permission flags in there. I'm sure all of you remember that from files too. There are permission flags in the usual things, read-only, system header, blah, blah, blah. But there's also a sparse flag in there, if you actually look carefully. And there are a bunch of these flags, and it turns out it's this bit which will, this too, this has a weird shot. That too represents a sparse file, a bit being set to designate. Now, the interesting thing is, when I create these sparse files, it only gets set in standard info. It doesn't get set in the file name attribute. It seems inconsistent, but at least the way I tend to see things happen. No argument. This is sort of, my real motivation for doing is try to understand file size. Well, for resident data, there's nothing. It's never sparse, so I didn't really just pass that up. So here's the actual documentation. What happens is, it's in the part of the data structure, in the data attribute, in the content. And so a lot of this refers, is called the content size, but really that is the size of the file. And it turns out that this in the recorder of the header of the attribute, if you actually look at the non-resident header attribute structure, it's got these things. And the one that never seems to be around is the size on disk. This is the new one that I, after, let's see, who's the oldest graduate here? Dave? What year were you grad? Yeah, did anybody reach 2013? 2013, anybody? So I've been doing this for a long time, right? I think, I want to say from 08 or 09 or something like that. And this is the first time it just sort of popped into my consciousness, which says probably I'm pretty thick or unimaginative or something. So I found these 4 file sizes, and the usual kind of stuff. This one is optional. Sometimes it's there, sometimes it's not. And that's the one that is interesting. And it seems it's automatically created whenever that sparse flag gets set. So it's not as soon as you remember that FS util set flag, sparse set flag, that doesn't only set the flag, it also creates this extra file size. And that's that was driving me crazy when I was trying to understand what was going on. Where did this new thing come from? And I haven't even thrown in it was 0 bytes before I even had anything going on. So I was seeing this thing being created, and that was driving me nuts. I was trying to understand what was going on. So this is what I'm pretty sure is going on for those 4 sizes. The first size is allocated. And here allocated is very strange. It means how many, if all the stuff was there, how big it would be. Remember those data runs with null clusters that are sparse? Those count in this allocated size. So it's there but not there. And in some ways that makes sense, because if you think about managing quota space, etc., that's actually what's charged to the user. Even though they think they're told they have this much, but they're only this much on space. It's kind of what's on disk when you have sparse going on. So the way you can actually find this is go into the data runs, pull out the number of clusters, and multiply that by the bytes of cluster, and you get this allocated size. So that's how much disk space the file. If the file were really there, this is how much disk space it would take. Kind of you can't talk about sparse files. It really sounds insane. That's the way it goes. If we're really there, this is how big it would be. The second is the actual size. And I want to say that this is what the operating system will tell you. If it's less than the initialized size, which is another little problem there. And so if you do a DIR, this is the one you're actually seeing. The actual bytes. And this is what, when you do a file open of any sort, the operating, this is how many bytes you're getting back. And if you think about what that's actually going to be, is the allocated, notice, so again, it's the allocated size, even those, including the things that aren't really there, minus a little bit of slack at the end. So that, that's how that guy works. And there is this little weirdness. Sparse clusters can't have slack space. It's, because they're just full of null bytes, and they'll consider all those null bytes count. The third one is the initialized size. And basically, when we do the set valid data, this is the thing that's getting changed. You're saying, oh, this is a, and so you can make it less than the actual size, and and if you do make it less than the actual size, you have, go ahead, Ben. Yes, yes, yeah, and most of the stuff that goes on, Ben's point is, if you start writing, that counts as initialization. But what you can do, and what FSU till will do is, you say, well, you don't have to write. We'll just make it initialized. You kind of do an end run around actually writing the data, which is why we got that stuff from unallocated space into our files. And if the size is, so if the initialized size is less than the actual size, what Windows does is return null bytes. Even if that, whatever was out there, this applies to non-sparse files, it will still return null bytes. So You could, if you had a big space, you filled it in. Now, what tends to happen is when you start creating files, it adjusts everything. The initialized size and the actual size become the same thing. Most applications do that. I haven't found any that don't, but I haven't tried a whole lot. Ben, does that help? Okay. So, so far so good. Then this new one, the size on disk, which is actually, and the only way I can phrase this is to look at the data runs with non-sparse clusters and use that number. So it's again, this number should be equal to the non-sparse clusters from the data run times the bytes per cluster. I know I say not well documented. I only have found one documentation for this, and it's sort of like in a footnote. Everybody else kind of skips over it. Well, actually, I've seen one person say that that value 40 we saw, 48 is always 40, and it's not. Carrier's book doesn't actually address it directly, but he doesn't mention this at all, that this size on disk. And in fairness to Carrier, I'm not sure if this was done when he was writing this book in the early 2000s, doing his research. So, but anyway, it is there now, and I've seen it. I've done this on more than one machine, so it seems to be fairly consistent. So this was sort of my big discovery, and then figuring out what the heck was going on. So, and if you haven't remembered, this is sort of files 2 refresher, that the data runs are specified by clusters for non-resident data, and data run basically is start here, go so far. Start at this cluster number, go for this so many. So, but it's got this really weird structure. If you've never seen it before, you probably have to go out and really study it a while. But those of you who have seen it before know that the first byte in the data run says, one nibble for how many bytes to use to specify the first cluster, one nibble to specify how many bytes to use for the size of the cluster. And this is the sort of thing that works out. I never have been able to figure out why they did it that way. Now, if the data run is sparse, this is the thing we've been seeing a few times. The first nibble of that byte is 0, and then the next nibble says how many clusters to use. So if we had 6D042 bytes clusters of null bytes, that's what it looked like in a sparse file. That's what data run looks like. So there's no second part. So here's actually the kind of the step-by-step construction. And so if you, and you wind up with very, very strange stuff going on. So here is a brand new file of 140K bytes. And so, and I've got the file size, and there are only 3 of them at the moment. So notice there are only 3 file sizes. And we have, because we're using create new, nothing's initialized. And it doesn't come out to the actual number of bytes doesn't come out to an even number of clusters. So you see that the allocated size is the actual size rounded up a little bit to the nearest cluster, basically, is what's happening. And then you see the data run at the bottom saying, where are those clusters? Turns out that 20 hexadecimal clusters, and here's that 35. 29, well, actually, that's multiplied to get the cluster, because there's 4K clusters here. So that's actually the starting point of the cluster, that 23 back up there. And so if you actually follow it out, it does all work out. So that's the sort of first step, creating a new one. And here's what happens when you do the set flag business, sparse set flag. Up in the standard information attribute, we get another flag set. And then inside, and here's the thing that just kind of boggles my mind. So this is still not a sparse file, but it's got the sparse file flag set up in the header. And then it adds this 4th file size. Right there. And then does some other weirdness out here in terms of the actual file use. I'm not quite sure why it did it, but it did. You can see that the data runs have gotten changed from the previous slide. Same guide. So I'm still using that stuff. So then what happens if we actually set the range, throw in some, make it really sparse, and so you see what happens. We have this situation. Here's the sparse data run, and it actually got some other stuff left over because it didn't come out nice and even. We'll have to talk about that in a second. And you notice now I've got 4 file sizes, and they're all different. We have the first file size is the allocated size. That's the bluish stuff. The next one, starting with E0, that's the actual size. And then the third one is the initialized size. Still haven't initialized anything. We're playing around with all this data, but we haven't initialized it yet. And then the fourth one says how much space is actually used on this. And this is where it differs. See the 3 up here? That represents 3,000 hexadecimal bytes of allocated, but actually only 2,000 used on disk. And so that's what that one new one was sort of the actual thing that kind of blew me away. The other interesting thing you notice is it came out. Why didn't it go for more clusters in the sparse? Turns out that it only will do multiples of 10 for the sparse data runs. So here's a little bit more of I did some of the math behind it. I'm getting close to time, so let me see. And so there's an interesting little feature. Set 0 data. It sounds like writing it all zeros, right? Initializing it. But notice what happened to the initialized size. Go figure. So I suspect it's writing it and now considering it uninitialized. There are actually null bytes out there, but they're not being counted. And I realize I'm getting close to time, so it's initialized, but isn't initialized. Let me get down to the last thing. You can play with this. I did a whole bunch of things because I know I'm getting close to time. Not my fault. We got started a little late. So first of all, as near as I can tell, they only occur in multiples of 10 hexadecimally hex clusters. I don't know which programs, including those of Windows, which play with sparse files. It's probably quite limited. Now, last night I found out, yes, you can use sparse data file, put sparse stuff in an alternate data stream. In fact, FSUtil works pretty nicely with almost anything you do with a file. You can do with an alternate data stream using FSUtil. In fact, I actually was able to do FSUtil create new x:y, where x didn't even exist, and it created x and the alternate data stream y, all at one fell swoop. And in fact, and then I gave it a size, and it made the alternate data stream the size, and made the carrier files, they call it, 0 bytes big. So it's a real quick way to put some stuff together. And something I always really, really want to make room for questions. Anything? See, Andy's stroking his thing. He's thinking. Go ahead, Dave.
I don't know why I want so many clusters of no bytes anyway, other than to save space.
Yeah, that's as near as I can tell. The one example I see in the documentation is sparse files might be used. You had a big database where lots of it was empty, and think about moving that database. That would be very helpful. Now the problem is they don't seem to move. So it just saves space on the actual disk. So you move it, it blows up, which is. Yeah, and I also found out in the last week or two, I think maybe even during a class, is the bad clusters are recorded in NTFS in an alternate data stream, which is sparse, and it doesn't have the sparse flag set. And it doesn't have the fourth file size either. So it's sort of like a, that's sort of consistent because Windows doesn't play with the NTFS files the way it plays with other files. It doesn't update it, Yeah, it does have, it's all sparse because how many bad clusters do you expect on a disk? 0. So it actually has it's one big sparse file. I couldn't make this stuff up, right? Okay, I suspect most of you know. Am I going the right way? Yep, yeah. You need to get in contact with me, J. Riley at bloomu.edu. And I realize we're just about out of time. Thank you!